Students, today you need to partner up with somebody who has a graphing calculator. Second of all, you need your your graphing calculator exploration sheet. I told you I was going to make a key for that for a video. The purpose of that is that you would follow through it so you know how to do the functions that we're doing on your calculator. And today we are going to use your calculator in that way. You might say, is this really necessary? Especially for those of you who are moving on to take AP Calc next year, you'll be expected to use your calculator for a variety of the problems. Half the test, you're required to have your calculator. If you don't, you'll struggle to get through it. So we're going to have a pretty short lesson today. I rewrote this worksheet last year to help you guys better, but we're going to look at a couple ways in which we solve equations and inequalities, but we're going to do it graphically. This is really important because you're expected to do this moving forward. Sometimes you get a function. I want to be clear here so you understand. X to the fifth minus x to the third plus the square root of 3 times x squared plus pi is equal to 1. And you're like, how would I solve that? I want you to know that there is no good way to solve that. Formula for the quadratic formula is this long, but for the cubic, it's a page and a half. The formula for the quartic is 4 pages in length. Formula for the quintic, we've actually proven that you cannot write a formula to solve the quintic or anything above that. So the only way you solve this is by a graphing calculator, and you have to be able to have that technology. I shouldn't say that. There is a method that we do in calculus, but it's very tedious and it takes a while. It's called Newton's method. Your calculator employs the very same method. It just is able to do it very quickly. So let's take one that we know how to solve, and we're going to solve it 2 ways. We're going to get used to using your graphing calculator a little bit. First of all, algebraically, 3x minus 2 equals 5 times x plus 2 minus 3. We all know how to solve this algebraically, correct? Piece of cake upside down. 3x minus 2 equals 5x plus 10 minus 3. So 3x minus 2 is equal to 5x plus 7. Subtract the 5x's. Negative 2x minus 2 is equal to 7. Add the 2. Negative 2x equal to 9. X is equal to negative 9 over 2, or negative 4.5. We're all good with that, right? You would never solve that using your graphing calculator. You would just do that by hand. It's faster. It's just good practice. But this, totally different scenario. I just did one that you know how to do, so then we can look at how you do it graphically, okay? So, graphically, first approach, we look for the intersection. I don't generally use this option, but I'm going to show it to you so that you understand that it is an option. And if we move to it at some point, you'll know what you're doing. So if we want to look at the intersection, we create 2 equalities. Y equals 3x minus 2, and y equals 5 times x plus 2 minus 3. Once I've created the 2 equalities, I go into y equals, and I type them in. 3x minus 2. So that we're in the same window, I'm going to press zoom standard, zoom 6. In my current window, can I see the intersection point? No. So I'm going to zoom out. There's 2 ways to do that. You can do a window and change it. So you could go by 20s or something like that. Or you can zoom out using the number 3 option. I think I'm pretty smart with the window. So I'm going to change the y values to be negative 30 and positive 30. I think that will allow me to see it. Yep, that allowed me to see it. You might say, how do I know what to do when? You don't. You got to be able to think that through. So now that I can see the intersection, I press second, calculate. You did this in previous years. Which option do I use? Which number is that? 5. Look at what your calculator is asking you to do. It's saying identify the first curve. Is y sub 1 equals 3x minus 2, is that one of the curves we want to find the intersection of? So I press enter on it. Then it jumps the cursor to another spot. And it says y sub 2 is 5 times x plus 2 minus 3. Is that our other one? So we press enter. It then asks if I would like to guess. I don't need to guess. So I press enter, and it's going to think, and it's going to find that, in fact, x is equal to negative 4.5. So we did second, calculate, and we pressed number 5, intersection. And we got x is equal to negative 4.5. There's a question up front here, kids. Go ahead and ask. You need to see it again? You sure? Positive. Anybody need to see it again? Okay, so we go second, calculate. We do number 5 for intersection. And if you can't tell what curve it's on, you can either move, so you can see which one's on, or you can look above and see, oh, it's 3x minus 2. Press enter on that one, then make sure it switches. See, I can move it up and down to transfer which curve it's on. So I want to make sure it's on my second one, enter, and then I enter on guess, and it will compute negative 4.5. Curve, yeah. So instead of delineating a difference between a curve and a line, most things that we graph are curves. Just happens to be that these are lines. Your calculator doesn't tell the difference. Okay, the second option we can have is to use our zero option. This is the option that I will just about always use. And what I do with the zero option is I set the function equal to 0. So I take 3x minus 2, and I subtract everything over to the other side. Now, I totally realize you could combine like terms and everything like that. But just think if we were using, example like this quintic equation up above. All right, you gather everything on one side, so you subtract the 1, and then you would type it into your calculator. You're going to y equals, I'm going to delete what I have there. And I've got 3x minus 2 minus 5 times x plus 2. And then I've got plus 3. Graphically speaking, what am I looking for? Where it crosses the x-axis, that's where it has a height of 0. So as I press graph, you can see that that's where it crosses the x-axis. Your calculator can find that out exactly. I should say to within about 1/10 million, okay? So we're going to go second, calculate, and which one do you think we grab up here? The 0 option, which is number 2. Now, this is where people get confused. We're not looking for where it crosses the y-axis. We're looking for where it crosses the x-axis. As I move over there, okay, what is my calculator asking for me, or asking me to do? What's the question it gives? Left bound. Your calculator asks you to move left and right. But really what you need is you need a spot where the graph is above the x-axis and a spot where the graph is below the x-axis. How do you navigate to above and below? You move left and right. So you know the answer is negative 4.5, correct? So I moved, is negative 6.5 to the left of negative 4.5? Yes, so I press enter. Now, as I move to the right of negative 4.5, you can see, sort of like negative 3, have I crossed over the x-axis? If you didn't cross over the x-axis, you would get an error. It would say error, no sign change. That would be a problem. I press enter, and sure enough, we get negative 4.5. What about your y value? What should the y value be? It should be 0. It's not. It's negative 1 e to the negative 12. What is that? Well, yeah, yours is 0 because you had a different window. Mine didn't. Why do I have that? You'll get it someday, trust me. What does it mean? Oh, come on. Come on, we got 32 of us. You're the best of the best. Close. 1 over 10 to the 12th. Very good, Darren. Nice job. He got it. Okay. That's what that means. Okay. Your calculator is stating this. When it says -1e -12, here's what it means. -1 times 10 to the -12. Well, if you were going to write that out as a decimal, it would be negative 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Approximately what number is that? 0. Let's change it. Suppose it was plus. That would be a really big number, wouldn't it? Like infinity. Not like infinity. Be more like what? 1 trillion. It's like our national debt. Um, what? It is. Right? We've been over a trillion for a long time. It'd be like no. It's like 18 trillion. We've been over a trillion for a long time. It's been like 20 years we've been over a trillion. I'm hoping we get to quadrillion in my lifetime. I mean, you hear the word trillion, don't you, from time to time? You hear the word trillion only because of our debt. Otherwise, you wouldn't hear that word, right? So, do you ever hear the word quadrillion? No, but maybe we'll get there. The race for 1 quadrillion. Let's go. Let's do it. Okay, so what do? We went second calculate. We grab number 2 and we press 0. And we got x equal to negative 4.5. Okay, we flip it over. I'm not going to do the intersection again because I just don't think it's very helpful. I want to go to graphically, and we're just going to get rid of this one. What's the difference between this problem and the previous problem we solved? Exponent and cube, and there's an inequality sign, right? So we don't want to just solve equalities. We also want to solve inequalities. What's the difference between the solution of an equality and the solution of an inequality? What? There's going to be answers that don't work, okay? More than one answer, there's a range of solutions, correct? So we're going to express our answer in interval notation to show the range of solutions. So I'm going to use the 0 option here again. I'm going to go 0.32x squared minus 3x minus x to the third plus 5 is less than 0. And you might say, I don't know what I'm doing. Well, yeah, you do. You zeroed it out. I get that you don't know how to solve that by hand. It's very complicated. It would take us many, many years. Okay? But I have a graphing calculator. (0.32x squared minus 3x minus x to the third plus 5. Before I press zoom standard, I want you guys to tell me, what does it mean for a graph to be less than 0? It means I'm below the x-axis. So we're wondering, where is this graph below the x-axis? Zoom 6. There's my graph. Looks like it kind of has that, a little bit of cubic shape to it. What about what number is that? Cross is at about 1, huh? So we'll just draw a picture here. Got about 1, something like that. So you tell me right here on the graph, am I above or below? Above, and below, below. So it looks like I need to find this spot right there, correct? Once I find that spot, will it be all the numbers to the right will work or all the numbers to the left will work? All the numbers to the right will produce negative results. How do I find that spot? So I can calculate, and I grab the 0. So I like the 0 option best. You can do the inequality one for here. I don't really like it. So yeah, let's see. Left bound. I'm going to go to my 0. I'm going to go to the left of it, and that's going to bring me above. I'm going to go to the right of it, and that's going to bring me below. I get 1.22. Now, 1.22 gives me a value of 0. So you tell me, what is my solution in interval notation? No. Shh. So this is good. This is good. This is a point that comes up all the time. Please let us into your brain. Tell us what you were thinking. You want to go from negative infinity to 1.22. Tell us why. Exactly. Okay. This is the point of confusion. Does everybody understand this? So you have two choices here. You either choose from negative infinity to 1.22, or you choose from 1.22 to infinity. Now, obviously, which set has more negative, which is the only set that has negative values in it? The first one or second one? The first one. These x values are negative, correct? Not all of them, but many of them are. That's not what we're looking for, though, is it? We don't care what the value of the x's are. We care about the outputs. So the question is, where is this function less than 0? For what x values will we get negative outputs? If you plug in a negative x value back here, do you get out a positive value or a negative value? You get out a positive value. It's way up there. But if you plug in a positive x value over here, like say 4, you're going to get a negative output, correct? And you can test that on your calculator by simply going into the table. Suppose we plug in negative 10. Will we get a negative or a positive output? And you can see you get 1067. We'll try 4. I said we would get a negative, and sure enough, negative 65.88. So it doesn't matter whether the x's are negative. What matters is the outputs. Does that clarify? The same questions come up every single year, and many people have it. So thank you for asking it. Got it? I've written a worksheet for you. There are 6 problems about equalities, and there are 6 problems about inequalities. I'm going to give that to you now.